Sodium.
Sodium is a chemical element with the symbol Na and atomic number 11. It is a soft, silver-white, highly reactive metal and is a member of the alkali metals. Its only stable isotope is 23 Na. The free metal does not occur in nature, but instead must be prepared from its compounds. It was first isolated by Humphry Davy in 1807 by the electrolysis of sodium hydroxide. Sodium is the sixth most abundant element in the Earth's crust, and exists in numerous minerals such as feldspars, sodalite and rock salt. Many salts of sodium are highly water-soluble, and their sodium has been leached by the action of water so that sodium and chlorine are the most common dissolved elements by weight in the Earth's bodies of oceanic water. Many sodium compounds are useful, such as sodium hydroxide, Li, for soap making, and sodium chloride for use as a de-icing agent and a nutrient, edible salt. Sodium is an essential element for all animals and some plants. In animals, sodium ions are used against potassium ions to build up charges on cell membranes, allowing transmission of nerve impulses when the charge is dissipated. The consequent need of animals for sodium causes it to be classified as a dietary inorganic macro mineral.
Characteristics. Physical.
Sodium at standard temperature and pressure is a soft metal that can be readily cut with a knife and is a good conductor of electricity. Freshly exposed, sodium has a bright, silvery luster that rapidly tarnishes, forming a white coating of sodium hydroxide and sodium carbonate. These properties change at elevated pressures. At 1.5 millibars, the color changes to black, then to red transparent at 1.9 millibars, and finally clear transparent at 3 millibars. All of these allotropes are insulators and electrolytes. When sodium or its compounds are introduced into a flame, they turn it yellow, because the excited 3s electrons of sodium emit a photon when they fall from 3p to 3s. The wavelength of this photon corresponds to the d line at 589.3 nanometer spin orbit. Interactions involving the electron and the 3p orbital split the d line into two. Hyperfine structures involving both orbitals cause many more lines.
Chemical.
Sodium is generally less reactive than potassium and more reactive than lithium. Like all the alkali metals, it reacts exothermically with water, to the point that sufficiently large pieces melt to a sphere and may explode. This reaction produces caustic sodium hydroxide and flammable hydrogen gas. When burned in dry air, it mainly forms sodium peroxide as well as some sodium oxide. In moist air, sodium hydroxide results. Sodium metal is highly reducing, with the reduction of sodium ions requiring -2.71 volts. Hence, the extraction of sodium metal from its compounds, such as with sodium chloride, uses a significant amount of energy. However, potassium and lithium have even more negative potentials.
Isotopes.
20 isotopes of sodium are known, but only 23 Na is stable. 2 radioactive, cosmogenic isotopes are the byproduct of cosmic ray spallation, 22 Na with a half-life of 2.6 years and 24 Na with a half-life of 15 hours. All other isotopes have a half-life of less than 1 minute. 2 nuclear isomers have been discovered, the longer-lived one being 24 Na with a half-life of around 20.2 microseconds. Acute neutron radiation, such as from a nuclear criticality accident, converts some of the stable 23 Na in human blood to 24 Na. By measuring the concentration of 24 Na in relation to 23 Na, the neutron radiation dosage of the victim can be calculated.
Occurrence.
23 Na is created in the carbon-burning process in stars by fusing 2 carbon atoms together. This requires temperatures above 600 megakelvins and a star of at least 3 solar masses. The Earth's crust contains 2.6% sodium by weight, making it the 6th most abundant element on Earth. Because of its high reactivity, it is never found as a pure element. It is found in many different minerals, some very soluble, such as halite and natron, others much less soluble such as amphibole and zeolite. The insolubility of certain sodium minerals such as chromite and feldspar arises from their polymeric anions, which in the case of feldspar is a polysilicate. In the interstellar medium, sodium is identified by the d spectral line. Though it has a high vaporization temperature, its abundance allowed it to be detected by Mariner 10 in Mercury's atmosphere.
Compounds.
Sodium compounds are of immense commercial importance, being particularly central to industries producing glass, paper, soap, and textiles. The sodium compounds that are the most important include table salt, NaCl, soda ash, Na2CO3, baking soda, Na8CO3, caustic soda, NaO, sodium nitrate, NaNO3, D and trisodium phosphates, sodium thiosulfate, Na2S2035 hours 2O, and borax, Na2B407 10 hours 2O. In its compounds, sodium is usually ionically bonded to water and anions, and is viewed as a hard Lewis acid. Most soaps are sodium salts of fatty acids. Sodium soaps are harder, higher melting soaps than potassium soaps. Sodium chloride is extensively used for anti-icing and de-icing and as a preservative. Sodium bicarbonate is mainly used for cooking. Along with potassium, many important medicines have sodium added to improve their bioavailability. Although in most cases potassium is the better ion, sodium is selected for its lower price and atomic weight. Sodium hydride is used as a base for various reactions, such as the aldol reaction, in organic chemistry, and as a reducing agent in inorganic chemistry.
Aqueous solutions.
Sodium tends to form water-soluble compounds, such as halides, sulfates, nitrates, carboxylates and carbonates. The main aqueous species are the aqua complexes plus, where N equals 4-6. The high affinity of sodium for oxygen-based ligands is the basis of crown ethers. Macrolide antibiotics, which interfere with Na+ transport in the infecting organism, are functionally related and more complex. Direct precipitation of sodium salts from aqueous solutions is rare, because sodium salts typically have a high affinity for water. An exception is sodium bismuthate, NaBiO3. Because of this, sodium salts are usually isolated as solids by evaporation or by precipitation with an organic solvent, such as ethanol. For example, only 0.35 gram per liter of sodium chloride will dissolve in ethanol. Crown ethers, like 15 crown 5, may be used as a phase transfer catalyst. Sodium content in bulk may be determined by treating with a large excess of arynyl zinc acetate. The hexahydrate, UO2, 2Z and Na, CH3CO2, 6 hours 2O precipitates, which can be weighed. Cesium and rubidium do not interfere with this reaction, but potassium and lithium do. Lower concentrations of sodium may be determined by atomic absorption spectrophotometry or by potentiometry using ion-selective electrodes.
Electrolytes and sodides.
Like the other alkali metals, sodium dissolves in ammonia and some amines to give deeply colored solutions. Evaporation of these solutions leaves a shiny film of metallic sodium. The solutions contain the coordination complex, Na, NH3, 6, plus, whose positive charge is counterbalanced by electrons as anions. Cryptons permit the isolation of these complexes as crystalline solids. Cryptons, like crown ethers and other ionophores, have a high affinity for the sodium ion. Derivatives of the alkali Na are obtainable by the addition of cryptons to solutions of sodium and ammonia via disproportionation.
Organosodium compounds.
Many organosodium compounds have been prepared. Because of the high polarity of the C-Na bonds, they behave like sources of carbanions, salts with organic anions. Some well-known derivatives include sodium cyclopentadienide, NaC5H5, and trityl sodium C6H5, 3-Na.
History.
Salt has been an important commodity in human activities, as shown by the English word salary, which derives from salarium, the wafers of salt sometimes given to Roman soldiers along with their other wages. In medieval Europe, A compound of sodium with the Latin name of sodanum was used as a headache remedy. The name sodium is thought to originate from the Arabic suda, st, meaning headache, as the headache-alleviating properties of sodium carbonate or soda were well known in early times. The chemical abbreviation for sodium was first published by Jöns Jacob Berzelius in a system of atomic symbols, and is a contraction of the element's New Latin name natrium, which refers to the Egyptian natron, a natural mineral salt primarily made of hydrated sodium carbonate. Natron historically had several important industrial and household uses, later eclipsed by other sodium compounds. Although sodium, sometimes called soda, had long been recognized in compounds, the metal itself was not isolated until 1807 by Sir Humphry Davy through the electrolysis of sodium hydroxide. Sodium imparts an intense yellow color to flames. As early as 1860, Kirchhoff and Bunsen noted the high sensitivity of a sodium flame test, and stated in Annalen der Physik und Chemie.
Commercial production.
Enjoying rather specialized applications, only about 100,000 tons of metallic sodium are produced annually. Metallic sodium was first produced commercially in 1855 by carbothermal reduction of sodium carbonate at 1100 DEGC, in what is known as the Deville process. A related process based on the reduction of sodium hydroxide was developed in 1886. Sodium is now produced commercially through the electrolysis of molten sodium chloride, based on a process patented in 1924. This is done in a down cell in which the NaCl is mixed with calcium chloride to lower the melting point below 700 DEGC. As calcium is less electropositive than sodium, no calcium will be deposited at the cathode. This method is less expensive than the previous Kastner process of electrolyzing sodium hydroxide. Reagent-grade sodium in ton quantity sold for about $3.30 per kilogram in 2009. Lower purity metal sells for considerably less. The market for sodium is volatile due to the difficulty in its storage and shipping. It must be stored under a dry inert gas atmosphere or anhydrous mineral oil to prevent the formation of a surface layer of sodium oxide or sodium superoxide. These oxides can react violently in the presence of organic materials. Smaller quantities of sodium cost far more, in the range of $165 per kilogram. The high cost is partially due to the expense of shipping hazardous material.
Applications.
Though metallic sodium has some important uses, the major applications of sodium use it in its many compounds. Millions of tons of the chloride, hydroxide, and carbonate are produced annually.
Free element.
Metallic sodium is mainly used for the production of sodium borhydride, sodium azide, indigo, and triphenylphosphine. Previous uses were for the making of tetraethyl and titanium metal. Because applications for these chemicals were discontinued, the production of sodium declined after 1970. Sodium is also used as an alloying metal, an anti-scaling agent, and as a reducing agent for metals when other materials are ineffective. Sodium vapor lamps are often used for street lighting in cities and give colors ranging from yellow-orange to peach as the pressure increases. By itself or with potassium, sodium is a desiccant. It gives an intense blue coloration with benzophenone when the desiccate is dry. In organic synthesis, sodium is used in various reactions such as the Birch reduction, and the sodium fusion test is conducted to qualitatively analyze compounds. Lasers emitting light at the D-line, utilizing sodium, are used to create artificial laser guide stars that assist in the adaptive optics for land-based visible light telescopes.
Heat transfer.
Liquid sodium is used as a heat transfer fluid in some fast reactors, due to its high thermal conductivity and low neutron absorption cross-section, which is required to achieve the high neutron flux. The high boiling point allows the reactor to operate at ambient pressure. Drawbacks of using sodium include its opacity, which hinders visual maintenance, and its explosive properties. Radioactive sodium-24 may be formed by neutron activation during operation, posing a slight radiation hazard. The radioactivity stops within a few days after removal from the reactor. If the reactor needs to be frequently shut down, NOC is used. Due to it being liquid at room temperature, cooling pipes do not freeze. In this case, the pyrophoricity of potassium means extra precautions against leaks need to be taken. Another heat transfer application is in high-performance internal combustion engines with poppet valves, where valve stems partially filled with sodium are used as a heat pipe to cool the valves.
Biological role.
In humans, sodium is an essential nutrient that regulates blood volume, blood pressure, osmotic equilibrium and pH. The minimum physiological requirement for sodium is 500 mg per day. Sodium chloride is the principal source of sodium in the diet, and is used as seasoning and preservative, such as for pickling and jerky. Most of it comes from processed foods. The dietary for sodium is 2.3 grams per day, but on average people in the United States consume 3.4 grams per day, the minimum amount that promotes hypertension. This in turn causes 7.6 million premature deaths worldwide. The renin-angiotensin system regulates the amount of fluids and sodium in the body. Reduction of blood pressure and sodium concentration in the kidney result in the production of renin, which in turn produces aldosterone and angiotensin, retaining sodium in the urine. Because of the increase in sodium concentration, the production of renin decreases, and the sodium concentration returns to normal. Sodium is also important in neuron function and osmoregulation between cells and the extracellular fluid, their distribution mediated in all animals by Na+/K+- Hence, sodium is the most prominent cation in extracellular fluid. In C4 plants, sodium is a micronutrient that aids in metabolism, specifically in regeneration of phosphoenol pyruvate and synthesis of chlorophyll. In others, it substitutes for potassium in several roles, such as maintaining turgor pressure and aiding in the opening and closing of stomata. Excess sodium in the soil limits the uptake of water due to decreased water potential, which may result in wilting. Similar concentrations in the cytoplasm can lead to enzyme inhibition, which in turn causes necrosis and chlorosis. To avoid these problems, plants developed mechanisms that limit sodium uptake by roots, store them in cell vacuoles, and control them over long distances. Excess sodium may also be stored in old plant tissue, limiting the damage to new growth.
Precautions.
Care is required in handling elemental sodium, as it generates flammable hydrogen and caustic sodium hydroxide upon contact with water. Powdered sodium may spontaneously explode in the presence of oxygen. Excess sodium can be safely removed by hydrolysis in a ventilated cabinet. This is typically done by sequential treatment with isopropanol, ethanol and water. Isopropanol reacts very slowly, generating the corresponding alkoxide and hydrogen. Fire extinguishers based on water accelerate sodium fires. Those based on carbon dioxide and bromochloride or methane lose their effectiveness when they dissipate. An effective extinguishing agent is MET-LX, which comprises approximately 5% renin sodium chloride together with flow agents. It is most commonly hand-applied with a scoop. Other materials include Lip Plus, which has graphite powder and an organophosphate flame retardant, and dry sand,